Hello everyone, welcome to Komal Vision's YouTube channel. Today's video is about factorization of polynomials in the 9th standard mathematics textbook. That is factorization of polynomials, which is very easy. Factorizing polynomials is very easy. Factor theorem. What is meant by factor theorem? First we should know what is meant by factor theorem. Factor theorem is nothing but for any polynomial, if p of x is a polynomial, okay, with the degree n is greater than or equal to 1, okay, and a is the any real number, a is any real number, okay, then the two conditions will exist. If we have a polynomial with a degree and also a as a any real number, so then we'll get two conditions. X minus a is a factor. X minus a is a factor. When it will be a factor means when p of a is equals to 0. That means p of some real number is equals to 0. And second one, p of a is equals to 0 when, got it? So the two conditions are here. First one is x minus a is a factor when, so x minus a is a factor when p of a is equals to 0. P of a is equals to 0 when x minus a is a factor. Okay, this is what the factor theorem statement. Let me just make you people revise once again. If p of x is a polynomial with the degree n is greater than or equal to 1 and a is any real number, then x minus a is a factor of p of a is equals to 0. X minus a is a factor of p of x when p of a is equals to 0. That is the first condition. And second condition, p of a equals to 0 when x minus a is. Now I will solve exercise problems in factorization theorem, that is regarding 4.4. So the first exercise problem, determine which of the following polynomials has x plus 1 factor. So the given polynomials, first one is x cube plus x square plus x plus 1. For which factor we have to find out? X plus 1 factor. So whether x plus 1 is factor or not for this polynomial we have to find, correct? So for this what I do is I'll simply find out the x value over here. X plus 1 is equals to 0. If I find out, this is called the 0 of the polynomial x plus 1. Okay, so if I find out 0 of the polynomial x plus 1 by equating it to 0, I can get the x value. X value will be minus 1. Okay, now I can substitute x value in this polynomial. So minus 1 whole cube plus minus 1 whole square plus 1 plus 1 it is. Okay, so now it is plus 1 plus 1. Wherever x you are saying, there I am just substituting x value because we got x is equals to minus 1. Now minus 1 whole cube is minus 1 itself, because any negative numbers odd power will give you negative number itself, plus minus 1 whole square is there, 2 is even number, so we will get plus 1. So here we will get here it was minus 1. Sorry, I forgot to substitute here. Here it was not plus 1, minus 1. So minus 1 plus 1 plus of minus 1 plus 1. This everything it cancels, we'll get 0. Okay, so since we are getting 0 here, x plus 1 is the factor. x plus 1 is the factor, okay, of the above polynomial. All we have done is we found the zero polynomial of the factor x plus 1, and then we found x value. After that we substituted wherever x present in this polynomial. Later on we got all the solutions get cancelled, all the terms get cancelled, and we got 0 as the remainder, which means x plus 1 is a factor. Can you remember the factor theorem now? If you get p of a is equals to 0, x minus a is the factor. If x minus a is the factor, obviously remainder should be 0. Okay, there is an interrelationship between remainder and factor. Now the second problem. For this polynomial, let us check whether x plus 1 is factor or not. So x plus 1 is equals to 0. If I equate, means I'll get x value is equals to minus 1. So I will directly substitute here. X is equals to minus 1 I'll get. So minus 1 whole power 4 plus of minus 1 whole cube plus of minus 1 whole square plus of minus 1 plus 1, which implies minus 1 whole power 4 is plus 1. Okay, and I'll write this as 1 itself because 4 is even number. Okay, and minus 1 whole cube is minus 1. Minus 1 whole square is plus 1 because the power is even number, and minus 1 plus 1. If you see guys, minus 1 plus 1 get cancels, plus 1 minus 1 get cancels. I am getting 1 here. Therefore x plus 1 is not a factor, of the given polynomial x power 4 plus x cube plus x square plus x plus 1. Is it okay? So 1 we are getting, we should get 0 here. And let us find out for third problem. So the third problem is x power 4 plus 3x cube plus 3x square plus x plus 1. We know x is equals to minus 1. So I'll directly substitute minus 1 whole power 4 plus 3 into minus 1 whole cube plus 3 into minus 1 whole square plus of minus 1 plus of minus 1 plus 1. Okay, now minus 1 whole power 4 is plus 1 because we have a even power. Minus 3 into minus 1 whole cube is minus 3, and plus 3 into minus 1 whole square is plus 3 because we have even power, and minus 1 will be plus into minus will be minus 1 plus 1. Plus 3 minus 3 get cancels, plus 1 minus 1 get cancels, we will get 1. Therefore x plus 1 is not a factor, of the above polynomial, Okay, so conclusion you should write like this. Now fourth problem is x power 3 minus x square minus of 2 plus root 2 close the bracket of x plus root 2, x plus root 2. Okay, we know x is equals to 1 here, minus 1. So I'll directly substitute minus 1 whole cube minus of minus 1 whole square minus of 2 plus root 2 of minus 1 plus root 2. Okay, now what we do is we'll just solve this step by step. Minus 1 whole cube is minus 1 again, minus 1 whole square is plus 1 again, minus into here 1 minus is there, minus into minus plus 2 plus root 2 plus root 2. Okay, since we forgot to take the minus sign inside of this bracket, that is very important. Let me just show you. 2 minus 2 minus root 2 into minus 1 plus root 2 I will write. Later I will just take the minus sign multiplication. So minus into minus plus, again minus into minus, plus root 2 plus again root 2. If you see, we are not getting 0 here. Therefore, the given x is equals to minus 1 or plus x plus 1 is not a factor. Not a factor. Okay. It is not a factor. So that's it. I hope you understood first main. We'll see the second main in the remaining mains in next video. Thank you.